Okay, in this next lesson, we're going to learn what it means to rationalize a radical. Rationalize a radical. And it's super smooth and super flowing, just like this avocado skating along. So, first and foremost, we need a rule, okay? When we rationalize a radical, we can take this and we can change it to be the same thing as, oops, I forgot a pen. Pen. Sorry. We can change it to the same thing as the square root of A over the square root of B, and vice versa. So if we see something that is like this, we can rewrite it as square root of A over square root of B. If we see something like this, we could rewrite it like this, because sometimes it's easier to divide that first and then take the radical. We can't divide this evenly. 36 divided by 121 cannot be divided evenly. But if you do notice, 36 is on our perfect square chart. 121 is on our perfect square chart. Way cool. If I use my rule, I can rewrite this. And the square root of 36 is 6. The square root of 121 is 11. And I can do that, right? I would love for you to try number 2. So you're going to come with this one finished. Follow the rule, rewrite it, using your rule, the square root of A over the square root of B, take both your square roots, and give me an answer, okay? Now, what about, and I would like you to flip this, okay? I would like this to be the square root of 27 over the square root of 3. That is a typo, and I'm sorry for that, okay? How could I rewrite that one? Well, I could rewrite it by my rule. I could do 27 divided by 3. And why do I want to do that? Because the square root of 27 divided by 3 is 9. And the square root of 9 is 3. Okay? So I would like you to rewrite this one. Use your rule, find what you're going to take, and find me an answer. Okay? So, you're going to come with 2 done, and you're going to come with 4 done. What about if we've got a problem like 5? What about if we've got a problem like 5? So what I want to do is I want to multiply across, okay? And I want to separate it as well. Here I have the square root of 72, and here I'm going to have the square root of 28. Now here's the thing. I need to make sure that those are written in standard radical form, and they're not. So I need to find out what the square root of 72 is in standard radical form and what the square root of 28 is in standard radical form before I can continue. Okay? And so, let's see. 72, well, you could do your factor tree. I can divide that by 2. 72 divided by 2 is 36. Now, do we even have to continue? Because we know the square root of 36. Do we have to keep going in our factor tree? Well, could. So, is that right? 72 divided by 2. 36, yep. 36 would be 6 times 6. I think we do need to. So 2 times 3. Ooh, this is weird looking. 2 times 3. That's okay. So, do we have any shoes? Here we've got a pair of 2s. Right there. And then we also have a pair of 3s. See the 3s? Okay. And then this 2 is all by itself. So we've got 2 times 3 times the square root of 2. That is equal to 72. So 6 times the square root of 2. Okay? Woo! 6 times the square root of 2. Okay, so that will go on top. Okay, now what about 28? We need to do 28. Well, 28, I could do 4 times 7. And this is a perfect square, but that one's not. So that stays underneath. So that would be 2 times the square root of 7. 2 times the square root of 7. Okay, so that's my answer. But here's the thing. We're going to learn in a few minutes that that answer really isn't done. Okay? And we're going to learn how to fix that. Because we're going to learn how to rationalize the denominator. Okay. So to rationalize the denominator, I'm going to write this down. I'm going to pause the video, write this down so that you can come back and just copy it down. Okay? Okay, here you go. You're going to multiply the top and the bottom of the fraction by the denominator in the form of 1. So as 1. So it's our giant 1. Okay, so when I say giant 1, I mean square root of 7 over square root of 7. So why did I use that? Because our last example had a square root of 7 in the bottom, and I can't have that. So we're going to practice rationalizing and simplifying to standard form. Okay, pause the video, write this down, and then we can go from there. Trying to make the video as short as possible. So, okay. I need to multiply this by my giant 1. So I'm not going to make a fancy 1 for this. What's my 1 going to be consistent of? My denominator is the square root of 5. So the square root of 5 over the square root of 5. Okay? So I'm going to multiply that. Here's why. Look, down here, what do I have? I have a pair of shoes underneath. And so how many 5s can come out? 1 pair. And then I have my 1 times my square root of 5. So I multiply across. The reason I multiply by 1 in terms of the denominator, or my giant 1, is because I want this radical down here to undo. Okay, so what am I going to multiply this one by? What's my giant 1 going to look like here? It's going to look like square root of 7 over square root of 7. Whoops. Okay, so this will undo on the bottom. So I will end up with a 7 on the bottom because I undid my square roots. And then I've got 2 times the square root of 7. Okay? All right. This one's a little bit tougher because I've got a square root of 3 on top, but it's not really. It'll be okay. We just have a few extra steps to get into standard radical form. A few extra steps to get into standard radical form. So what am I going to multiply this by? What's my giant 1 going to say? I'm hoping you said square root of 8 over square root of 8. Okay? So, I'm not going to do the bottom. I want you to do the bottom, but I am going to do the top. I'm going to have to do the bottom because I have to show you something at the end. Never mind. What's going to happen on the bottom? These are going to undo, so I'm just going to have 8. Okay? And then I'm going to have 6 times the square root of, what's 8 times 3? 24. Now, 24 is not in standard form, so I need to get my 24 into standard form. Okay? Are there 2 numbers that involve a perfect square? Or can you do your factor tree for 24? 24? Well, I know that I can multiply it by 4, and that's a perfect square. So if I do the perfect square method, I know that I can multiply 4 and 6 together. Cool. Can I simplify 6 anymore? I can't. But I can simplify 4. So what's this equal to? What's going to come out of the 4? A 2 times the square root of 6. So, but here's the thing. I have this 6 out here. So I've got 6 times 2 times the square root of 6 all over 8, right? I need to go one step further. I need to multiply this. What's 6 times 2? 12 times the square root of 6 over this 8. Now, can I simplify these? I can divide both of those by a number. What number? 4. Good. So if I divide this by 4, I get 3 times the square root of 6. If I divide this by 4, I get 2. So that's my final answer. So when you're doing these, you're going to undo, 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 and you're going to get rid of your denominator. You're going to undo your denominator by multiplying by 1 in terms of the denominator. If I need to put my number into simplest form, I'm going to. If I have a number outside, like my 6, I'm going to multiply that through. And then, if I can simplify my fraction, I will. It would be maybe a good idea to rewind this a little bit and write down those steps. All right? Come with questions. Nothing to do for notes. You should have all this down. So just completed notes for grade. And I'll see you. God bless.